Hello, everyone. I'm here to talk to you about databases. This is my second presentation for ITM course. So here we go. Introduction, I'm going to give the definition of a database, kind of the background information of a database, the history of a database. RDBMS, we'll learn more about that acronym later. SQL, NoSQL, those are different types of databases, MapReduce, and examples of databases. So the definition of a database is a structured set of data held in a computer, especially one that is accessible in various ways. So what kind of data does a database really need to be holding? Customer names, product amounts, expenditures. Data is going in and out of businesses constantly, and databases are essential to them to function properly. Back in the day, programmers processed files directly into the computer rather than having a database do it for them. That means that there was a ton of code written that's really time consuming, and time is money in the business world. This resulted in something called a database. As time went on, they became more efficient. IBM originally came up with the idea for SEQUEL around 1970. Relational management database system is a type of management system that's based on making sure that atomacy, consistency, isolation, and durability are attributes of the database, being used. Other features are typed columns, normalized data. It supports broad, unrestrained queries, and it's consistent way of accessing data. A lot of people are liking this, more so than just disregard that. Yeah, a lot of people are liking this. The definition of SQL is a standard interactive and programming language for getting information from and updating a database. Although SQL is both an ANSI and an ISO standard, many database products support SQL with proprietary extensions to the standard language. SQL is a common query language. It enables unrestrained queries. It's geared toward joins, filters, and aggregations, and it relies heavily on query optimization. The CAP theorem is just, something that is something that has to be fulfilled while a database is undergoing a task. It has to have consistency, it has to have available, and it must have partition tolerance. It has to keep all the data in line so that when it has to be accessed, it is accessible, it is readable, and it is applicable. Okay, so the next one is NoSQL, which is a class of database management systems that do not follow all of the rules of the relational DBMS and cannot use traditional SQL to query data. Some requirements need something different. Google and Amazon decided to make their own stuff because it offers controllability, stability, and it's cost effective. NoSQL can be kind of like compared to Linux in a few ways, like if you're an analogy person. What is it exactly? Well, it doesn't support complicated queries. It doesn't have a structured schema, and it's designed to be distributed. It drops all the ACID requirements of SQL databases, and it does not. I mean, it is dependent on the vendor, which is why, like, companies such as YouTube and Amazon have chosen to go with these type of databases, because those are companies that are growing. So if you have a database system that's designed to be distributed, it's going to obviously cater more to companies that are expanding rapidly. It's available, it's guaranteed availability, it's updated frequently, and it will become more consistent in the future, because data is only coming into databases more and more every day, and there's not really a sign of a lack of data in the near future. Types of NoSQL is column store, key value store, document store, and graph store. All of these are really just kind of ways the data is configured in the database itself, or organized, rather. Organized would be a better word for that. So yeah. Eventual consistency is something that must be obtained. Thanks to the distributed model, any server can answer any query. Servers communicate at their own pace, and the server that answers your query may not have latest data. MapReduce is one of the most common large queries. In RDBMS, this is usually pretty expensive. It involves a full table scan with a select. In some NoSQL, it is automatically distributed. Google can run a MapReduce among all their nodes in 30 minutes. All functions are distributed among all nodes to process, and the result is automatically returned as part of the vendor's framework. Some problems with NoSQL is that it's inconsistent between NoSQL providers. They must retain a normal data encode. There's not a lot of real operational power, and there's a lack of complicated queries. Here's a few examples of what NoSQL powers. As you can see, geared towards more companies that grow rapidly. Thank you.